Mm. Okay, so to start with, when we're going to do these quadratic equations, the first thing I want you to remember, did anybody go back and look at them? Look up what quadratic equations are? Remember those? What's that graph? Parabola, right? Right? And that is my x squared. There, my x squared is making that turn on the parabola. Do you remember when you first started factoring, you just had that part right there and you had to factor them, and then they said set it equal to 0? What are we trying to figure out when we solve, and why do we set it equal to 0? That 0 is my y. That is where I'm going to cross the x-axis. If I'm anywhere on this x-axis, what is y equal? 0, right? So what I'm looking for when I'm finding my two answers here, I'm looking for the x-intercepts. And you know that when you're crossing the x-axis, y equals 0. That's your x-intercept. That's what you're looking for when you set this equal to 0. Okay? Now, it's not always going to look like this. Sometimes it might be up above, in which case, when we got to that, we'd end up with a situation where we'd say there is no solution, right? Or it might, what's the difference between this one and this one? Anybody remember? Exactly. That's a positive A, and that's a negative A, right? All right. So just a little bit of background. When I have this, I'm going to break these down. I'm trying to break these down to those two binomials, yes? When I have this, and C is positive, when I have a positive C, my two binomials are going to have the same sign. Remember that one? What if I have ax squared plus bx minus c equals 0? And I break this to those two binomials. One of these guys is going to be positive, and one of them is going to be negative, right? Where does C come from? First, inside, outside, last. Remember FOIL? When I multiply these last 2 points, that's my C. So the only way that could be positive or negative is if one of them are going to be a positive and one's going to be a negative. So to start with, we're going to go to our example 1. There you are. All right, we've got x squared so this time I'm starting with just a binomial, right? So I'm not going to factor it down into 2. But what do I have? I've got an X in this one and an X in this one. So when I have the same thing show up in more than one term, I call it a what? Always, always, always look for that common factor because you can simplify it out. So the only thing that I can factor out of this quadratic is the X. And that's going to leave me with X plus equals 0. Okay, now no matter how long you've done quadratics, everybody, we still have a problem with taking that last step. Because you're not done yet. You don't know what your answers are yet. You have to set both of those equal to 0. If I have A times B equals 0, what do I know about A and B? Somebody's got to be 0, right? Somebody. I can't have a 0 here in the answer if one of these guys is not a 0. So I'm going to come here and I'm going to say, all right, this X equals 0 or X plus 6 equals 0. So my solution set is 0 and negative 6. Make sure you take that last step. Because if you don't, I promise you on a multiple choice, 0 and positive 6 will show up, right? So you got to make sure you take that last step and get the right sign on your answers, okay? So what does that mean? When did I put that marker down? That means that if I were to graph this x squared plus 6x, it's going to cross that axis at 0 and at the negative 6. Okay, that's what I just found out about this quadratic. One of the things that makes this 1.2 extra important, guys, is it all comes back in 4. Okay, and a lot of it's going to come back in 5. So we're going to need this factoring business several times throughout this course. You really want to know how to factor the quadratic equation. All right, I have 2x squared equals x plus 3. What's the first thing I'm going to get straightened here? Set it equal to 0, exactly. So I got to move these two guys. So I'm going to have 2x squared minus x minus 3 equals 0, right? I'm going to move those other two over to the other side. Now, trial and error. Anybody on AC method? Yeah. When A is greater than 1, you don't get to just factor. What I do is I multiply A times C, and I'm going to put it in that box. And then I'm going to put B in this box. So what is my A times C? Mm-hmm. And what's my B? Good. All right, so here's what I'm looking for. I need two numbers. That if I multiply those two numbers, I get a negative 6. But if I add those two numbers together, I'm going to get a negative 1. They got to multiply to negative 6, but add to negative 1. What is negative 3 times 2? It's my negative 6. And negative 3 plus 2, there's my negative 1, right? Okay, so I'm going to bring down my 2x squared. And I'm going to bring down that negative 3. But instead of a negative 1x, I'm going to break it up into those two terms right here. I'm going to say plus 2x minus 3x. If I have plus 2x minus 3x, isn't that still just a negative 1x? When you are doing your quadratics, and you had 4 terms. 4 terms was your key that it was time to do what? Whenever I have 4 terms, that's where I'm going to group my terms together. Now, what can I pull out of my first 2 terms? 2x squared plus 2x. What can I pull out? What can I factor out? So that's going to leave me with x plus 1, right? Now, I got to be able to factor something out of this one that when I do, I create another x plus 1. What could I pull out of this one? Exactly. Negative 3x divided by negative 3 leaves me with an x. And negative 3 divided by negative 3 leaves me with that plus 1. Okay. X plus 1 has now become my common factor, right? So I have 2x minus 3 times x plus 1 equals 0. And we're at our very, very last step. 2x minus 3 equals 0, and x plus 1 equals 0. So if I have 2x minus 3 equals 0, I've got to add 3 and divide by 2. And that's going to give me x equals 3 halves. And if I have x plus 1 equals 0, then I have to subtract that 1, and x equals a negative 1. So my solution set is going to be negative 1 and 3 halves. Getting some recall back. So let me ask this, since I have so many new people, how many people are planning on going on to 114? That's it? Okay. So you're going to get that doubled up book, right? 112 and 14. So you don't end up buying them twice. Okay. Come on. All right, so let's start with, how about an easy one? We're going to go z squared plus z minus 6 equals 0. Oops, that's not what I wanted to do. My c is negative. Now this time my a is 1, right? So I get to go ahead and just factor. My c is negative, so I know that one of these is going to be positive and one of them is going to be negative. It's a lot shorter to get there when my A is just 1, isn't it? I'm going to put this Z here and this Z here. Now I'm still looking for the same thing. I need something that'll give me a -6 if I multiply. But if I add, I get a +1 this time. What do I get? So Z plus 3 and Z minus 2. Last step, Z plus 3 equals 0, and Z minus 2 equals 0. Plus 2. Solution set. Put something in your notes right here. Star it out, something. This is not the answer. Too many times people will get to that point, look at their multiple choice and say 3 -2. It's not finished there, is it? All right, we're going to try 23. 23, and we're going to want to use that AC method on 23, okay? Can I clear? All right, so we're going to start with 4. Move that 12x over. Get it in your quadratic form. Yes? All right. A, C. So 4 times 9 is 36. And B is -12. -6, -6. Good. So I'm going to break that down to 4x squared. There's the 9. But instead of -12, I'm going to write so far, okay? You got to talk to me. I don't know if you understand what I'm doing or not. I have no clue, right? Until you say how you're doing. But too often, people sit there silently, no input whatsoever, and then after the test, well, I didn't understand any of it. I can't do anything about it at that point, guys. Get involved. I promise. All right, 4 terms. 4 terms says group. Yes? So I'm going to put them right now. What can I pull out of 4x squared minus 6x? 2x, good. So I'm going to pull that 2x out. 4x squared divided by 2x. And minus 6 divided by 2x. Yes? What can I get out of negative 6x plus 9? That's going to leave me with a 2. Watch those signs. 2x minus 3. So if I pull out a negative 3, negative 6x divided by negative 3 leaves me with a 2x minus. All right, now that 2x minus 3 has become my common factor, yes? They're the same thing, aren't they? So all I have to find is 1. 2x minus 3 equals 0. Add that 3. 2x equals 3. X is equal to 3 halves. How come I only got one answer that time? What does that look like? It's not crossing my x-axis 2 times. What do you suppose it's going to do? So it's just going to, on that line, excuse me, at 2/3, my parabola is just going to touch. And then go back. All right? In one solution. Yes, sir.
And so it's always going to be like one solution with a pairing of the same grouping.
Mm-hmm. Yeah. And we're going to, I haven't talked about it, so I didn't do it, but we're going to talk about on the square root method, which would probably have been a better way to finish off this answer. All right, should we do 27 or step on? Move on? Okay. All right. I got to take my cues from you guys. Okay, so we're going to talk about the square root method. Okay? If I have x squared equals 5, why do we call it the square root? Because I take the square root of both sides, right? Square root of x squared is 5 plus or minus square root of 5. Just taking the square root of both sides, right? All right, what about if I have x minus 2 squared equals 16? This time when I take the square root of both sides, the square and the square root are like plus and minus. They're going to wipe each other out. So over here, I've got x minus 2 left. Equals plus or minus, right? Got to use that plus or minus. Because 4 times 4 gives me 16, but so does negative 4 times negative 4. That gives me 16 also. So I got to use plus or minus. Going to add that 2 to both sides. Now I have 4 plus 2, and I have negative 4 plus 2. So what are my solutions? X equals 6 and negative 2. Yes? All right. So just real quick about 32 and 33. You can always say, can we do If you see a different problem up there you'd rather. Okay? So right now, let's just do real quick 32 and 36. 33. We now have the sign-in sheet. Has it made its way all the way around? Everyone? If you come in late and I've already had people sign in, make sure you sign before you go out, okay? Or before you leave. All right, 32. X squared equals 36, square root of both sides. That's not what. X is equal to a positive or negative. X minus 1 squared equals 4. Square root. X minus 1 equals to plus or minus 2. Adding the 1 to both sides gives me 2 plus 1 and negative 2 plus 1. So my answers are going to be, write them more properly. Yes? All right. What we need to do, remember those special circumstances? Like, what did we consider x squared minus 9? What did we call that? The difference of squares, right? And we didn't have to factor that. We knew that if I subtracted 2 squares, that could always break down to plus or minus the roots. Yes? Didn't even have to. All I needed to know was what was the square root of 9. Okay? What about the trinomial square, guys? When I'm talking about the square root method, how did I build up? Because what I want to create is problems like this. Because when it got like this, that was pretty easy, wasn't it? Square root, add the 1. That made that really, really simple. But I need a certain type of trinomial. I need that trinomial square. Remember that? When I have a trinomial square, I have an ax squared my c is going to be twice, let me put this up, twice the square root of b. Okay? I'm looking for some numbers. Let's have x squared now that will factor for me. But if I want that trinomial square, I want to take my b and I'll divide it by 2 and square it. So my b is 8. 8 divided by 2 squared, 16. All right, so I'm going to get rid of that 7. And instead of having a 7 there, I'm going to have a 16. Whatever I do on one side, of course, I got to do on the other, right? Okay. What can I multiply to get 16 that will add to 8? Wouldn't both of them be positive 4? Right? X plus 4 times x plus 4. So how could I write that? Instead of x plus 4 times x plus 4, I could write that as, there you go, equals, now I've got that problem. Now I got this easier. Because all I got to do is take the square root of both sides. Come on, you. And I've got x plus 4 equals plus or minus 3. Subtract that 4. And I've got 3 minus 4 and negative 3 minus 4. Gives me negative 1 or negative 7. Completing the square. Right here. Ooh, you all should have called me out. I left my square off of there. Completing the square right there. That's going to hit you 4 more times this semester. Okay, you want to know how to complete the square. You want to know how to write me a trinomial square. Okay, so Google Words, right? YouTube, right? Did anybody go into Wolfram Alpha and check out that website that was here last week? What about a teaching, an instructional site, guys? Khan Academy. Khan Academy is another good one that will go through an entire lesson with you. And then you can actually practice problems too, and it'll grade for you. All right, let's go to, so the main reason there is for being able to solve this stuff multiple times. The whole reason there is because sometimes it's easier to do one way and sometimes it's easier to do another way, right? All right, so when A is 1 and B is even, it's always easiest to complete the square. If A is greater than 1 or B is odd, then don't do it. Use your formula. It doesn't make any sense to. When I have x squared plus 4x, put that 21 over there. Complete that square so I have a trinomial square. B divided by 2 squared. 4 divided by 2 squared. What's that going to equal for me? So I'm going to add a 4 to both sides. Right? What can I multiply to get a 4 and add to get a 4? So that's going to be x plus 2 times x plus 2, right? Which I get to write as x plus 2 equals square root of both sides. X plus 2 equals plus or minus 5. Subtracting that 2. 5 minus 2 and negative 5 minus 2. My solution set is going to be negative 7 and 3. Excuse me. All right, try 38 for me. What am I going to add to both sides? 6 divided by 2 squared gives me, yep, multiply to a positive 9, add to a negative 6. What's that going to break down to? X minus 3 squared equals 22. Square root of both sides. X minus 3 equals plus or minus square root of 22. X is equal to 3 plus the square root of 22, or 3 minus the square root of 22. Yes? All right, 2 more problems. I know you're ready to go, but I do still have 10 minutes. And we have not talked about the quadratic formula. What is the quadratic formula? Square root all over 2x, right? So if I've got 3x squared plus 2 equals 4x, I need to write that in my quadratic form. So 3x squared, which should come next. I don't want that 4x over here. I want a 0 over here. Plus 2 equals 0, right? A, B, and C. So negative B gives me a negative 4 plus or minus negative 4 squared minus 4 times 2 over 2 times 3. Negative, negative 4. Plus or minus. Negative 4 squared is a 16 minus 24 gives me, they did not. Is there something wrong with my math I am not seeing here? 12, 20, they sure did. They gave me a negative right out the box. All right, negative over 6. All right, 8 doesn't have a square root, but does it have a square factor? What can I break 8 down to? 4 plus the square root of 4 times the square root of 2 gives me 4 plus 2 times the square root of over 6. What's going to simplify there? 4, 2. So I'm going to have 2 plus or minus the square root of negative 2 over 3. All right, work on looking at more examples of that. One thing that I did want to mention is that the class after you guys